Section 10.3 Confidence intervals for the difference between two means, pair samples. Objective number 1. Construct confidence intervals with pair samples. We have a formula in d bar minus t alpha divided by 2 as d over square root of n for the left hand side, and the right hand side we have d bar plus t alpha divided by 2 times sd over square root of n. D bar is the sample mean of the difference, and sd is the sample standard deviation. Mu d is the population mean difference. We will explain the d bar, sd, and mu d for later. Let's look at the example number 1. Does drinking a small amount of alcohol reduce reaction time noticeably? 16 volunteers were given a test in which they had to push a button. In response to the appearance of the image on a screen, their reaction times were measured. Then the subjects consumed enough alcohol to raise their blood alcohol level to 0.05%. They then took the reaction time test again. Their reaction times in milliseconds are presented in table below. The row label difference is the increase in reaction time after consuming alcohol. A negative difference occurs when the reaction time after consuming alcohol is less. So we have the table below. The data show that the sample mean reaction time increased after the subjects consume alcohol. We would like to construct a 90% confidence interval for the population mean increase mu d. So first of all, let's understand this a little bit. The problem explained to us that the negative difference occurs when the reaction time after consuming alcohol is less. So for example, you look at the difference -1 for the first person or -11 for the fifth person. With alcohol 0.05%, the time that they react take them 102 seconds. But without alcohol, it took them 103 to react. Or the same thing for the fifth person, 85 and 96. So you see that with the alcohol, it took them less time. So that's why they said that after consuming alcohol is less when you see the number negative. So how do we get the number -1, and then 1, then 8, and so on? What do they do is they take the difference. They just subtract. 102 minus 103 is -1, 100 minus 99 is 1, and so on. So those numbers, -1, 1, 8, 11, -11, and so on, we call them, they are the difference. To find the mean of the difference, we use the Excel. So to find the mean, the notation is D bar, and we use the Excel. We do equal average, and then we highlight the yellow numbers. And to find the sample, standard deviation SD, we have the Excel command is STDV, and then we highlight the number. For this section, you notice that we have match paired. Match pairs mean we have exactly 16 people with the blood alcohol 0.05% and the blood alcohol 0 with the 16 people again. For the other section 10.1 and 10.2, you may measure 16 people. And then for the second time, you may measure 15 pupils. You don't have to be much, but for this section, it must be much for the numbers, okay? If you use Excel, you will get D bar is 6.5 and SD is 9.933311. So we just go ahead and do the problem, and then I will explain the meaning of that. So we're going to use the formula. Mu D represents for the population difference, and is equal to the sample difference, the sample mean of the difference, minus T SD over square root of n, and then D bar plus T SD over square root of n for the right hand side. We plug in the D bar, which is 6.5, minus T is a critical value. We will calculate using the confidence interval. The n, in this case, we have 16 people, so n is 16. So the problem gives us 95% confidence interval. And the right tail and the left tail is 2.5%, which is 0.025. So to find that, we're going to use T and the degree of freedom. We have 16 minus 1 is 15. And we're going to use the tail right side, so 0.025. We map this number together, and we got the T value is 2.131. Then we copy for the left hand side for the negative, because the student distribution is also symmetric. So we put in the number 2.131 and positive 2.131 for the right hand side. So we calculate, so we get mu D is 1.2 on the left and 11.8 on the right. So let's explain the meaning. When you have the mu D between the two positive numbers, that means mu D is a positive number. When mu D does not contain 0, the interval does not contain 0, it means that mu D, all of the value of mu D is positive. And do you remember mu D? Mu D is the mean average of the difference. When it's positive, then we can be fairly certain that the mean reaction time is greater when the blood alcohol level is 0.05%. So let's go back and look at the table. So when the number is positive, the blood alcohol level for 0.05% is greater. So let's look at the table, and let's pay attention to the positive number. And this is just a sample. We just make the conclusion for the population. Okay, so for example, I have 1, 8, and 11. Do you see that in 0.05%, the first row, 177 and 61. Compare with the second row, 99, 69, and 50. So the 0.05% is greater than. Okay, so we conclude that we are 95% confident that the mean difference is between 1.2 and 11.8.